This is chapter number 13, Simple Linear Regression Analysis. In this chapter, we will study how to use regression analysis to predict the values of dependent variable based on the values of independent variable. Like you will have one independent variable, you will have one dependent variable. From this set of observations, we will try to predict this dependent variable on the basis of this independent variable. For example, here price and demand. Demand is dependent variable and price is independent variable. For example, demand is depending upon price. If price goes up, demand goes down. If price goes down, demand goes up. Similarly, uh, price and supply are also dependent and independent variable. Supply is depending upon price, so price is independent. If price goes up, supply goes up. If price goes down, supply goes down. Or similarly, uh, if we say that price and let's say price and land area. Now land area is independent variable and price is dependent. Price is depending upon land area. If you increase land area, your price will go up. If you decrease land area, your price will go down. So in this way, from these three examples, you can analyze that it is not necessary that every time price is independent, so it depends upon the situation. So you will be given two variables, you need to decide which one is dependent and which one is independent variable. So correlation versus regression, a scatter plot can be used to show the relationship between two variables. So this is what we do in regression. Correlation analysis is used to measure the strength of association between two variables. This correlation tells us that how much two variables are interlinked with each other. So uh, here you can see that if we draw them graphically, linear relationship, for example, if you plot x and y and you see all these dots, and if you draw a straight line, now this straight line covers the maximum points. Maximum points are on the line or very close to the line. But similarly, if I draw here a curved line, here I cannot see any point, so this is not a curvilinear, this is a linear relationship. Similarly here, if you draw x and y and if you see the behavior of points are like this, and if I draw a curve, now this curve is touching maximum points and most of the points are very close to this curve, so this is a curvilinear relationship. So depending upon their relationship, we draw x and y, we see is it linear relationship or curvilinear relationship. If it is linear relationship, then we use this equation, linear equation. If you remember in fundamental mathematics, that was our linear equation. So we will use this linear relationship to analyze, to predict dependent variable on the basis of independent variable. This is a strong relationship because most of the points are very close to the line. This is a weak relationship between most of the points are not very close to the line. Here we cannot see any relationship. As I said, regression analysis is used to predict the value of dependent variable based on the value least at least one independent variable. So we will see how does it works. So only one independent variable x, relationship between x and y is described by a linear function. If you are given only one x and one y, most of the time, not necessary, but most of the time it is a linear relationship. So we will use a linear equation like this. Here they are using beta naught plus beta 1x. These beta 1 and beta naught are coefficients, are constants, so we can write it in this form, a plus bx as well. So here a is our beta naught, b is our beta 1, so that does not matter what notation do you use, and this is error. So we can minimize this error by applying some mathematical formulation. So I show you that what is that mathematical formulation. Like here you can see that if we say that there is a linear relationship y equals to a plus bx, Now first this is our equation 1. We apply sum on this first equation. If I apply sum on this first equation, this n a is a constant, it will become n times a plus b times sum of x. That is our second equation. Now I apply sum of x. Apply sum of x on this first equation. When we apply sum of x, it will become sum of xy equals to a sum of x b sum of x squared. So now we have these two equations to predict, to analyze dependent and independent variable. Whenever you will be given a data, you will apply these two equations and we can predict independent variable on the basis of we can predict dependent variable on the basis of independent variable. So when we know a and b, when we substitute, after calculating a and b, we substitute them back into this equation a plus bx. For example, whatever a, you get a naught, you get b naught. You substitute them into this equation, then we denote it y hat a naught plus b naught x. After finding a and b, we substitute them into this linear regression and we call it estimated linear regression equation, and we denote it with y hat, where b naught or a is the estimated mean value of y when the value of x is 0, and b1 or b is the estimated change in the mean value of y as a result of 1 unit increase in x. So here we solve one example, like a random sample of 10 houses are selected. Here we have data house price and square feet. As I said in the beginning of this lecture, it is not necessary that price is always independent, but here you can see price is dependent variable, which is y, because price is depending upon land area, and x is independent variable. Now we try to estimate regression equation for this, and as I said, when it is a linear relationship, first you plot this x on x-axis, y on y-axis, and you will see the behavior of all these points. If it is like a straight line, then you will use this equation y equals to a plus bx, and out of this equation we draw two more equations, which are n times a plus b sum of x and sum of xy a sum of x plus b sum of x squared, right? So I will give you one example. Here we have quite big data, it is time taking, so I take a simple example to predict it. For example, I write it here. Let's say I take a random data, x is, let's say 4, 15, 3, 10, 15, 9, and I take a random data for y, or I give you I solve this example on a separate page or in a attached example, so rather than solving it here. Anyways, here when you will do all that calculation which I just skipped, and I will attach it in a separate file as an example, so where you will see all the calculations. When you will get, that is your a 98.24 and that is your b 0.10, you will substitute them back into the regression equation. It will become y hat 98.24 plus 0.10 x. So this will predict our dependent variable on the basis of independent variable. For example, whatever you want to interpret, you can substitute any x and you can get the predicted value of y, house price. For example, here house price is this, b naught estimate mean value when the x is 0, that is, we have already explained it here. Now what it says, If beta is this, tells us that the mean value of house price increased by point this and 109.77 on average for each additional 1 square foot of size. And if I say what would be the price if the land area is 2000. As I said, you can predict independent variable on the basis of you can predict dependent variable on the basis of independent variable. If I say that if I choose land area is 2000 square feet, you simply substitute here 2000 and you will get the house price. That is the ultimate objective. So one important thing is you can see the minimum value of x and maximum value of x. You can predict within this range. You cannot say that if I say x is 500, what would be the house price? No, it would give us a wrong estimate. To get the right or best estimate, we have to substitute x within the range of x. For example, minimum value of x and maximum value of x, then you can get the right prediction.